So after determining whether we have polar or nonpolar molecules, so what is the implication of this polarity? Okay, molecules are attracted to one another. So just like the planets are attracted with other planets or stars with other stars. Okay, so molecules are attracted to other molecules. Some of these interactions are weak or attractions, while some are weaker or stronger by comparison. Okay, so what are these interactions? So we call this as noncovalent interactions. So noncovalent interactions is a collective term for all the forces of attraction other than the covalent bonds, ionic bonds, or metallic bonds. So these non-covalent interactions is found in a molecule. But if that non-covalent interaction is already applied to one molecule attraction with other molecule, we call that as intermolecular forces of attraction. So this is called as IMFA or IFA or IPA, interparticle forces of attraction. So this differs in the school. So in UPLB, in which I graduated, we call this as IMFA. But in UP Diliman, they call it as IPA. So I don't know if uh, maybe that is because of the books that we read. So we use the term IMFA or intermolecular forces of attraction. So other schools call this as IMF, intermolecular force. Okay, so much for the differences. Okay. So please take note this intermolecular force. So this means that the interaction is between one molecule to another molecule. We also have intramolecular force, which is the attraction within a single molecule. So inside the molecule, aside from the covalent bonds, there are attraction between atoms. So we call that as intramolecular forces of attraction. Okay, but we'll focus on the non-covalent interactions. Okay, so we have three non-covalent interactions. The first one is LDF or London dispersion force. So this occurs in all molecules. So, and this is caused by attraction between positive and negative ends of non-permanent dipoles in adjacent molecules. Okay, I have a diagram showing how the dipoles are created or how there is a polarity. Okay, so yeah. For example, initially we have a non-polar molecule. So this can also occur in a polar molecule. Okay, so here the molecule 1, for example, this one rotates. Okay, so what happens when a molecule or even as rotates? So some of the particles inside the molecule are thrown in one side while some retains because it has a stronger mass. For example, the proton or the nucleus of an atom is very massive. So that means if an atom rotates, so one end will still have the nucleus, but on the other end we have the pushed electrons. Okay, so this is just like uh, the, our example molecule in which after rotating it could create an instantaneous dipole. So we have a separation of charges. So again, instantaneous, this only means that this one occurs at an instant. So if this instantaneous dipole is connected with or is placed near another nonpolar molecule, so this instantaneous dipole, since it has negative charge, this will attract the positive charge now on another nonpolar molecule. And this one is what we call the induced dipole. So again, this one is instantaneous, so this means that after some time it will go again as a nonpolar molecule. And at the same time, the induced dipole will also be nonpolar again. So this happens in all molecules. That is why LDF, or London dispersion force, occurs in all molecules. Next, we have the differences between LDF. Okay, so which molecules have stronger LDF? Okay, LDF increase with increased number of electrons in the molecule. So if we have a bigger molecule or higher molar mass, this thus we have stronger London dispersion force. Moving on to the second non-covalent interaction, we have dipole-dipole force, or DDF. So this only occurs in the polar molecules, wherein we have a permanent dipole. Okay. So if we have the London dispersion force occurring from an instantaneous dipole, this will induce another dipole in another molecule. For the dipole-dipole force, we have a permanent dipole. So this means that since this is permanent, the negative and the positively charged parts of two molecules, so they will be attracted strongly or stronger than the induced and instantaneous dipoles. So this one is stronger than London dispersion force. So again, if we compare which molecules have stronger DDF, the more polar a molecule is, the stronger its dipole-dipole force. So how is that? If we have again higher molar mass or bigger molecule, we also have stronger dipole-dipole force. Okay. And the last one is a special type of dipole-dipole force, wherein this only occurs when a hydrogen atom is bonded to oxygen, nitrogen, or fluorine. This is what we call the hydrogen bonding. Okay, we all know that water has hydrogen bonds. Okay, so that is one example. So this one is the strongest non-covalent interaction. Okay. So for example, NH3 ammonia, we have hydrogen bonds there. H2O or water, HF or hydrofluoric acid, we also have hydrogen bond. Okay, so last, before we have the 10-minute mark, okay, problem. So again, try to answer this first, pause this video. Okay, so go. Okay, so let's answer this. Okay, ammonia has LDF, PDF, and H bonding. Nitrogen gas is nonpolar, therefore it only has LDF. Carbon monoxide has LDF and DDF, and carbon dioxide is nonpolar, LDF only. So take note that all have LDF. Okay, so that's it for chapter 7. Thank you.